Hello and welcome to the MADByTE tutorial part 2, what to actually do with your data once you've done all the peak picking and processing that you have on your normal data set. So MADByTE is going to look through the different data directories that we have here. So for instance, if we have erythromycin and we go through the pdata folder, what you'll see is that we've still got that peak.txt file, and that's what we're going to end up using for our overall processing. So we're going to want to select the master NMR data directory, and what this is going to be the directory that contains all of your different experiment files. So for this case, I have called it hand annotated because I've gone through by hand and annotated these compounds. And you want to make sure that you've correctly selected what kind of data archive it is. So for this case, they're Brooker directories, they're in the Brooker format, so I want to carry that through. So the next part is going to be selecting the project directory. And for this, we recommend actually naming each project directory pretty well. So for instance, if I wanted to do something like this year's standard compounds, I'll do standards. And we'll be able to select this folder as our data output. So this folder will contain all of the data that we get from processing it through MADByTE, as well as some tables that allow you to look at the distribution of different resonances across each experiment. The next step is to set the NMR parameters. So how close do the proton resonances have to be considered the same point? Same thing for the carbon and the consensus error. So how well the HSQC and TOXY must match before it is considered the same point or a different resonance. So once we've loaded these parameters, we'll be able to run MADByTE. So MADByTE takes a minute as it starts to look through the data structure for that. So just be a second. And you can kind of keep an eye on it if you pull up your terminal window. And this will let you know what's going on, so you can see that it's creating the different output directories for each thing, as well as starting the processing. So if we actually go into what that looks like, inside of each one, we will have different files from various stages of the processing. These are mostly used for troubleshooting, but can be pretty interesting to take a look at depending on what your intent is. And you'll see here that it's generating a correlation network. So what's happening here is it's comparing each resonance feature to each other resonance feature that it has seen in the data set that you submitted. So for instance, if I had a whole different set of data that I wanted to keep separate from these hand annotated compounds, I would simply make a separate directory and run this analysis. And that way the correlation matrix is only comparing samples that I've looked at before. So once it is all completed, you should be able to go back and we will perform the networking step.